In the previous episode, you learned about heat as a form of energy that can be transferred through conduction, convection, and radiation. You identified the conditions that are necessary for these processes to occur and perform activities that allow you to investigate the different modes of heat transfer. Now, you will learn about another phenomenon you encounter in everyday life: electricity. You must be familiar with this since electrical energy allows us to operate appliances, gadgets, and machines, to name a few. Aside from these man-made devices, the ever-present nature of electricity is demonstrated by lightning and the motion of living organisms, which is made possible by electrical signals sent between cells. However, despite the familiar existence of electricity, many people do not know that it originated from the motion of charges. But what are the different types of charges? How can objects be charged? What constitutes a complete electrical circuit? To answer these questions, let us describe the different types of charging processes. Before we begin, let us first describe what electricity is. It is a set of physical phenomena associated with the presence and motion of matter that has a property of electrical charge. There are two types of charges, namely the positive and the negative electric charges. Did you know that objects can be charged in different ways? To prove this, let us perform these experiments to describe the different types of charging processes. In the first experiment entitled, "Comb My Hair," we will need the following materials: comb or supply, and the small pieces of paper. Bring the comb near the pieces of paper. What have you observed? Right, the small piece of paper did not attach to the comb. This time, brush the comb in your hair. Do this thoroughly. Place it near the small piece of paper. What have you observed? Great! The small pieces of paper were attracted to the comb. Why did this happen? This happened as electrons move from one surface to another, resulting to attraction of one object to another. This is what we call as charging by friction. In the second experiment entitled, "To charge or not to charge," we will need two balloons. Tie the two balloons and place them in an iron clamp. Charge the first balloon by rubbing it off your hair. Place the charged balloon as near as possible to the other balloon. But take note that they do not touch each other. Touch the charged balloon and remove it. Observe how the two balloons interact. For the third question, what do you think is the charge acquired by the balloon after rubbing it against your hair? The balloon gained negative charges. For the fourth question, in which part of the activity did polarization occur? Charging by polarization happened the moment we placed the charged balloon as near as possible to the other balloon, without the two objects touching. Neutral charges present in the second balloon were separated when the charged balloon was placed near it. What is the purpose of touching the charged balloon? It is used to discharge a charged object in a process called grounding. Were you able to charge the second balloon? Yes! This happened because the neutral charges of the balloon were separated. What do you think is the charge of the second balloon? If the first balloon was negatively charged, then the second balloon is left positively charged as its negatively charges were grounded the moment you touched it with your finger. In the last experiment entitled, pass the charge, we will be using the materials used in the second experiment and follow some of its procedures. Let the first balloon setup from Activity 2 touch the second balloon. Separate the two setups, then observe how the charged balloon interacts with the first and second setup. For question number 8, were you able to charge the second balloon? Yes! Through charging by contact, charges of the balloon in the first setup flow towards the neutral charged second balloon. Is it necessary for the two balloons to come into contact for charging to happen? Yes! For charges to flow towards a neutral charged object, the two objects need to be in contact. Lastly, from your observation in the last step, infer the charge acquired by the balloon in the second setup. The balloon in the second setup gains some of the first balloon's positive charges. Lastly, where would these electric bulbs light up? In an open or a closed circuit? Observe closely. The light bulbs glow when circuit is closed, allowing the electric current to flow freely in the wire, while it stops to flow when the switch is turned off, thereby opening the circuit. Let us summarize what you have learned in this lesson. The law of conservation of charge states that charges cannot be created or destroyed, but can be transferred from one material to another. The total charge in a system must remain constant. There are two types of charges, namely positively and negatively charges. There are three types of charging processes. Charging by friction involves rubbing a material with another, resulting in electrons moving from one surface to another. Charging by contact or conduction involves the contact of a charged object to a neutral object. Lastly, charging by induction or polarization involves charging an object without touching the object to any other charged object. Now, let us apply what you have learned in this lesson. Look for other substitute objects found in your homes to demonstrate the charging process by friction, induction, and conduction. Create a vlog showing your understanding of the concept, if possible. Recall the experiments done previously. Describe the type of charging processes involved in each picture. Write a 2 to 5 sentence reflection at the end of the lesson. Please do not forget to subscribe to our YouTube channel, Math Cycle, like the videos, and hit the bell button for updates. I hope you learned in today's lesson. On the next quarter, we will learn about Earth in the perspective of a scientist. This is Sir Leonard, your science teacher. See you all next time.